Hello and welcome to the R&D Mathematics. Today we are going to talk about systems of linear equations. So systems of linear equations. So as the name sounds, now more than one equation. Now in this one, let's say you have x plus y equals 3 and let's say 3x minus 2y equals 4. Now this is a simple example. So we are going to talk about things like that. Now, these are, if you try to draw them, these are linear equations. So both of them are actually lines, right? Now, a question, how many different ways that you can draw two lines on plane? So two lines on XY plane. Now, let me show you. So, pause the video and think how many different ways that you can draw two lines in the XY plane. Actually, there are three ways. See, for example, it can be something like that. That means they intersect, right? There is a chance that they might intersect. Or it may be the case like this. They will never intersect. They are parallel. So in this first case, they intersect. And in this case, they are parallel. And there is another case, a third case. Now let me try to draw it over here. That's the case. So see, it may be the case you have this line and the second line is also that line. So two lines on top of each other. Now in order to clarify this, let's say this y equals x plus 1. So here 0, 1. Let's say it's a line like this, and what if I multiply this whole thing by 2? Then I get 2y equals 2x plus 1, 2x plus 2. That's still the same. Oh, 2y minus 2x equals 2. See, different labels, but still they are the same. Oh, 200y equals 200 plus 200x. Still the same. See, different labels, different names for the same line. So that can happen in an equation. So these are the three cases. In these three cases, in the first one, exactly one solution where they meet. That is your solution. So one solution. So the solution is expressed in x comma y form because that's a point on xy plane. And in this case, no solutions. And in this case, infinitely many solutions. Now let's have a look at these cases separately. Now next, let's say in this case, see x minus 1, that line, and y equals 4x plus 2, those two lines actually meet in this point right here. So the solution is actually negative 1 comma negative 2. This is the solution. Now if your system is like this, this is your system, it can appear like this. So this is your system and the solution is this. So one way is to draw the graph and get your solutions. How about this? Still, same category. This place right here is the solution. In this case, that's 3 comma 1. Solution is 3 comma 1. How about this? Now in this case, no solutions. Why? Because they will never meet. It looks like they are parallel. Actually, we can double check it. Take this guy, and if I simplify this, 3x minus 4 equals 4y, right? So if I rewrite it, y in my left hand side, I get this. If I divide this by 4, I get minus 1. Now carefully look at these two equations. See here the slope and see here the slope. Same slope, and that's why they are parallel but two different y-intercepts. See here 3, here negative 1. See it goes to 3 and goes to negative 1. So that's why they will never meet. So no solutions. And in this case, how about this? In this case, actually two different labeling, but it's the same line. Let's take this and simplify. So 2y, if I take x to the other side, 5 minus x, and if I divide by 2, I get 5 over 2 minus x over 2. if I rewrite this, minus 1/2 x plus, actually, see, there's a printing mistake. This should be 4. This should be 4. So I have 4, 4. So 4 over 2, which is 2. And see, same. So actually, now it's clear. There are 3 different cases. But the thing is, you cannot actually keep graphing equations all the time. So we are going to algebraically solve them. Now let's take an example. How about this example? So this first technique is actually substitution method. So as the name sounds, what we are going to do, we are actually going to use substitution. That means we solve for one variable in one equation. You know, the first thing that you have to do, label them. So let me call this guy 1 and let me call this guy 2. So the first equation and second equation. And then from second equation. So get used to this kind of writing. From second equation, it's really easy to simplify for x. X is going to be 3 plus 2y, right? Now you put this value, put in 1. Put in 1. Then what will happen is, so 1 is 2x. 1 is 2x plus 3y, but 2 times, now the new x is this, plus 3y equals 4. See what happened now. This equation 1 now becomes a new equation, new one. You can call it 3 if you want, but the thing to note is you don't see any x's here. You only see y's now. So when I simplify this, I get this, right? So you can keep simplifying. 7y equals negative 2, and then add this step y equals negative 2 over 7. And now what you need to do, you need to take this value back and plug in. It doesn't matter which equation, either 1 or 2, or right here. It's much easier to plug into this because we already solved for x in 2. So x is going to be 3 plus 2y, but the y is this one. So 3 minus 4 over 7, and when we simplify, 7, 21 over 4, so 17 over 7. Now at this point, you can plug these two values back in your original equations and check. I really recommend you to do that, but I'm not going to do that in this video, so please check it. That's going to work. Now let's see more examples. How about this? Now you guys pause the video and try it. Okay, assuming you have tried it, see, they already have labeled it. If they have not labeled them, I recommend you to label it. Now from this one, if you actually try to simplify, what's going to happen? So from second one, again, I will catch the second one. Second one, it's easy to simplify for x, 9y minus 12. So x is going to be, when I divide by 3, 3y minus 4. Now I will put this back in 1. You have to put it back in the other equation because you just solved it from the second equation. Now you have to put it back into the first equation. So for 4 times 3y minus 4. So put in 1 plus 5y equals 18. So now we have an equation just consisting of y. So 12y minus 16 plus 5y equals 18. So I get 17y, and when I take this 16 to the other side, I am getting 34 in this side because 16 plus 18 is 34. And when I divide by 17, 34 divided by 17, which is 2, which is a nice value. Now put this value back here to find x. So x is going to be 3y. So 3 into 2, 6 minus 4, which is 2. So our solution is 2, 2. This is a way to express, and I really recommend you to plug these two values in both of the equations, not just one, both of the equations, and check it. Okay. Now that is the first technique, substitution method. But the substitution method is not the easiest for all examples. There is one method that will work for all examples. That's the method that I prefer. Elimination method. Now in this method, let's take this simple example and try it. In this method, actually we are getting rid of the variable. You know what, let me explain it while doing it. So first of all, you have to understand this. So let's say a equals b. This is an equation. If I multiply both sides by any number, 10a equals 10b, these two equations are equivalent, right? See, for example, if you say x equals 5, this is same as saying 5x equal 25, right? So you have to have that idea. So that means if I multiply both sides of any of these equations by the same number, it's still the same, right? So what if, just look at these numbers, carefully look at these numbers, and using that idea, what if I multiply first equation by -2? Let's do that. What if I multiply my first equation by -2? What will happen here is, when I multiply first equation by -2, I will get -2x plus, well, sorry, not the first equation, the second equation. Second equation by 2, -2x plus 4y equals, let me choose the same color. So -2x plus 4y equals 6, right? Now, first equation, I don't do anything. I will just leave it as it is, because what I did was I actually make these two numbers so that they will cancel when I add these two equations. Now, if I add these two equations like this, x's will cancel and I get -y. So if I add this left hand side and right hand side, what I'm getting is I get -y equals 10, right? And give me a second here. Sorry, here I make a mistake. I made a mistake. Did you catch it? I made a mistake. Here it should be, when I multiply by -2x minus 4y equals -6. And then when I add these two values, I get not 10, -9, because -5 and -4, -9 equals -2. So again, -2. So when I divide by -9, negative over negative is positive, y is this value. See, this is much easier. In one attempt, we are actually getting rid of one variable. Now, it's simple. Now, at this step, you just need to take this and plug it in one equation. I will plug this value back in equation number 2, because it's easy. So, x plus 2 times y is now this value, you know that's going to be 3. So, when you solve for x, you are going to get 3 minus 4 over 9. Right, and then 20, 9 times 3, so 23 over 9. So this is my x. So our solution is x comma y solution is 23 over 9 and 2 over 9. You can check that by plugging. Now the real thing to learn here, looking at these numbers and how to get rid of one variable in one shot. Now, let me explain another thing. Now, this part is actually, well, I recommend if you are a beginner, just rewrite the equation after multiplying. But once you get the hang of it, let me show you, you can skip that. You can, let me use a different color. And once you label this, what you can do is equation number 2 multiplied by -2. Oh, it's better to write the other way around. So -2 times equation number 2, and then you add it to first equation. So this whole thing, I made it into one simple notation. So equation number 2 multiplied by -2, and let's add it to first equation. Now in your mind, equation number 2, -2, so -2x, and with first equation, -2x and x is gone. And y's, -2 into y, -4y, and here -5y, so we have -9y equals right hand side. Negative 2 into 3, you get negative 6, and when you add, you get negative 6, and 4, you get negative 2. See, this step, without avoiding all these things, you can just do it like that if you are comfortable, and then after that, these steps. Okay, let's do another example. How about, let's see, how about, you know what, let's go and let's take this example that we did with substitution method, and let's redo it. So let me erase, and we have 2 comma 2, remember that 2 comma 2, and let's see whether we can get the same value by this technique, elimination method. This is the method I prefer, and this is the method that will always work, and which is easy for anything. Now if you see these numbers, okay, now the numbers are a little tricky because 4 and 3, it's not, see, you can get rid of x or you can get rid of y, that's your choice. Let's say I like to get rid of y. If I want to get rid of y, what would I do? You know, pause the video and think about it. If I were you, this is what I would do. I would multiply first one by 9. 9 times first one, because then I make this value into 45. And then I add second one, I multiply it by 5. Because then I will get this value into negative 45. So positive 45 and negative 45, it will get rid of y value. But since this is, you know, let me go ahead and rewrite everything. So 9 times 1, so 9 into 4, 36x plus 45y, and 9 times 18. Let me write it like that. And then second one, 5 times, so 15x. So I'm adding these two. 15x minus 45y equals, so 5 times negative 60. Now, when you add, see, these will cancel. Yes, you can skip this step and do it in your mind if you are comfortable enough. And then when you add these numbers, 51x equal, and then here you have this, and then if you add them, 1 or 2, which is nice because when you divide by 51, x is 2. See, same result, we obtained it. And then you plug it back here and you get the same y value. Now let me ask you this question. What if you wanted to get rid of x? What was your procedure? Well, in that case, let me do so. If I want to get rid of, look at these numbers, 4 and 3. So first one by 4, sorry, first one by 3. So I will make 12x. And second one, I will multiply it by negative 4 to make it negative 12. And then let's add them. Now let's, you know what, let's do this in our mind. So first one, negative 12, when I multiply by 3, 12x. And second one, negative 4. So negative 4 into 3, negative 12x, x is gone. So let's look at the y's. 3 into 5, you have 25y in the first one. And then negative 4 into negative 9, 36y. And the constants, we are looking at 3 into 18, which is 54. And negative 4 into negative 12, positive 48. And I'm getting 102. Again, 51y equals 102, and y equals 2 in this case. See? Yes, it's correct. And when you plug it back, you can do that. You will get x equal to as well. So that is the idea, guys. Now, you know what? To give you more practice, let's say you had 8y 7x plus 12y equals whatever the numbers, just, I'm not going to solve them, but what if, how to get rid of this? In this case, what would you do? In this case, let me make it into 3y. In this case, if I were you, I will actually get rid of y by doing this. So I will multiply first equation by 4 because then I will make this guy into negative 12, right? And then just add second equation, negative 12 and positive 12, they are gone. So you only have an equation involving x, right? How about these numbers? In this case, what, just pick some values. In this case, I don't see anything especially easy, but again, I would go with, y. I would get rid of y because I see positive and negative. It will make it easy for me. So I will multiply first one by 11. Sorry, 11 times first one and add to 5 times second one, because when I multiply first one by 11, I will make this place negative 55y, and this place 55y. I just need to add. Yes, you can go get rid of x. In that case, you will have to multiply with a negative number. For example, let's say if I want to get rid of x, I will first multiply first one by 7. So I'll make this 21x and add to the second one multiplied by negative 3. So I'll make this in this place into negative 21x. So this is the, so negative 3 times second one. This is the trick. This is what you need to learn in elimination method. Okay, guys, that's it for today's video. Thank you.